Welcome to our session Connect with Control M. Today we focus on accessing S3 resources in a secured fashion, utilizing the IAM capabilities of the cloud provider. In our agenda for discussion today, we have a few different topics. First off, we start off with an overview what IAM is and how we benefit from that capability of the cloud provider, executing the setup for the AWS infrastructure in order for us to allow access to these resources, perform tests, and ultimately execute Control M workflows and folders in order to access these resources. And take a look at the behind the scenes. How did we get this all to work? To set the stage, we have a fictitious company called Red Cycles. We have a marketing team and a sales team. Both of them need to work together and have access to shared resources. However, in certain instances, the marketing team is not allowed to access sales data, and the other way around, the sales team not allowed to access the latest marketing activities. So there needs to be a separation between accessing these different resources. And from a Control M perspective, as we execute folders and jobs, we need to be able to properly utilize these access restrictions. It all is centered around the identity and the authorization that we have in place. If we focus first on identity, who am I to the system and how can I be authenticated to the system? What role do I take over? Do I impersonate a different role? Who am I to the system and will be properly authenticated? The other aspect on the authorization side would be then, if I assume a certain role, what resources can I access and which resources do I have no access to? Now, if you think about this from a overall execution perspective, we have 6 different areas that we need to look in. First, into how do we govern access to these resources and understand the concept behind the scene, creating these different resources, users, roles, and policy, and see how they work with each other in order for us at the end of the day have a data-driven workflow and execution that can consume the data, push the data out there, or do something with the data. So as you can see here, the items in green are the ones that we need to set up our infrastructure, and the one in orange focuses on the business orchestration and the consumption of the data. So let's take a look first on the governance side. What is it that we actually need? So if you want to run this in your own lab environment, you first need to have an AWS account with proper permissions to create the different artifacts. You need to have a Control M environment with an agent that is running and can communicate. And we utilize under the cover the AWS CLI as well as the automation API. That means a good understanding of JSON is very helpful. So let's take a look at our different resources that we have. We said we have an EC2 instance as we downloaded the script. So let's SSH into our instance and sudo into the agent itself and execute a communications check. As this one is running, just a quick reminder, we have an EC2 instance running in AWS with a Control M agent. We have on the other side an enterprise manager and a server. The firewalls are configured that only the server can connect to the agent, and no other IP address out in the internet has access to this agent, and the agent is not allowed to initiate any communication to the server. So for this demo environment, we kept it really secure on how these systems can talk to each other. So we can see agent can talk to the agent, the agent can talk to the server, and the other way around. We have that properly set up. And now we take a look at our EC2 instance. We preface them with ZZM as our naming convention. Instance is up and running. And one thing that I would like to point out is here in the bottom, you see the IAM role. Currently, there is no role associated with that instance, which means that anything that is running inside the OS cannot switch any roles or do anything in particular. Let's leave our agent here and authenticate as a different user. Now, what we want to take a look at is that we have access to the AWS resources. The AWS CLI is installed, and there are really two files of importance here. Let's clear our screen and show them one more time, which is the configuration file that tells the API in which region we are going to execute our calls by default. And the next file is going to be our credential files. And here we will want to highlight that we have not specified a secret key or an access key in order to authenticate against AWS and then perform certain operations. This is all empty because we have as a source for our authentication the EC2 instance itself. The metadata of the instance is being pulled in when it's going to execute. So if we switch over back to our EC2 instance, this will be here identified by the IAM role. Why is that important? Because we don't want to save any secure credentials information in any text file on the system. Now, if you were to modify this with the GUI, you go into Actions, under Security, and modify IAM role. This, when you created your instance via the GUI, you can manage the role association that you can see here on the screen. So key takeaway really that we currently have no configuration for the API here and therefore no access to these resources other than what the EC2 instance can inherit. Okay, so that would be the first part. We have all the bits and pieces in play, but how does IAM actually help us with our scenario? So let's take a look at how identity and access management is doing that for us. Well, what's the goal of IAM? Well, the goal is to set and manage guardrails and provide fine-grained access controls for the users or the workloads, any entities that need to have access to AWS resources and artifacts. It's there to manage the identities across a single AWS account or across multiple accounts. And the main purpose here is that we want to grant temporary security credentials to the user or to the API that is invoking these calls so they can access the AWS resources properly. How does it work under the cover? Well, IAM, we can specify the services and resources to have that access to these resources. It will analyze these different permissions, and if we enable the default credential provider chain, it will go through these different components. As you can see here, there are 6 listed in total. There are about 8 different settings. The first one combines the AWS and the Amazon environment variables. And when we enable the default provider chain as a component to authenticate our identity, and we don't have environments variables set or they have values that don't make sense, guess what happens? It goes to the next stage. It goes to Java System Properties, and it would work its way all the way to the last one here, the instance profile credentials. And if at the end of this we still don't have proper access, or being rephrase this, we don't have properly authenticated ourselves to have a role in place that we can use, then all access will be denied. How does it play over to Control M? Well, as we touched on, the secret key and the access key are used in combination and maybe saved in clear text for the API or in our connection profile saved so that we can access these resources from anywhere in the world. But we don't want to have this kind of access. We want to control the access and govern how this is being utilized. And therefore, the EC2 instance is a means for us to put on different roles, different hats. And we need to identify the role that we would like to use. This is where we have the role ARN. And the second one, we need to tell the SDK that is being used under the cover, that the default credential provider chain is being activated or that is being utilized. So as we tell the CCP go and use the chain, it will then utilize the ARN and goes through this chain in order to figure out, are we at any point in time properly identified and authenticated. On the right hand side, you see some of the artifacts that we need to create in order for this to work all properly. And now let's take a look on how these will be interacting with each other. First thing would be, I really would like to have access to an S3 bucket. So I'm requesting the system to have to grant me access to these resources. Well, from a Control M perspective, we have the centralized connection profile. It has two main component, the role ARN and the secret key that it will going to utilize on the agent. Since the agent is running on the EC2 instance and it will be able to inherit different roles, now let's walk through this mechanism to identify how we have access to these resources. As you can see, there is a dotted line and there's a purple line. The roles, the policies are intertwined with each other. One is granting permissions and the other one is accepting the request or trusting someone to take on and ask for these permissions and inherit these permissions. So the first one would be the EC2 instance needs to have the permission to change the role as well as to have a temporary security token. This needs to be assigned to the EC2 instance. And by means of the policy, we identify which entitlements do we have and which permissions can we inherit. So once this is hashed out that we have the permission to switch roles, we need to figure out which roles are there for us to consume and what kind of permissions do we have. And here you see that now the role for the S3 bucket as well as for the policy, they work also together. They will help us to identify, do you have permissions to assume that role and what kind of resources do you have permissions to access and with what kind of level do you have access to these resources. Once this is all hashed out and figured out, guess what? Our CCP is going to be happy because now is going to have access to the S3 bucket, or access will be denied. If we were to utilize the AWS CLI just by itself, we can be even more granular in how we allow access to these resources and make a few of these resources visible. However, from a Control M perspective, we want to be also user friendly. So there is a challenge. On one side, we can be very, very restrictive and give certain permissions. On the other hand, we want to make it user friendly. So this path that we have to walk there for Control M requires that we add a few more permissions that we add only to make it easy for the user to consume these resources, just to keep that in mind. Okay, we have access to these resources. We covered the governance side. Now it's a good time for you to pause the video and take a look at the different IAM capabilities and how they influence the execution with the provider chain. We want to continue here and identify next the AWS S3 buckets and the resources. So what do we need to have? Well, we need to create some buckets here for sales, marketing, and shared. And we're going to utilize the AWS CLI in order to do this. Of course, you can utilize the web interface as well. And the key takeaways for this one would understanding the S3 ARNs, keeping track of this information, and the APIs that we are going to utilize is the API to create a bucket, and then just for testing purposes, if everything is working fine, we're going to copy a file. So let's take a look at our live environment here. The first thing that we want to do is create a bucket. And as this bucket is running through, go and get a coffee. I don't promote any coffee. I have some other drinks in my BMC cup here. Sparkling German water. No, sparkling water. So here we see now the first phase in our management of our buckets is to create the buckets itself. And as you can see, as the script is being executing here, we have here the bucket information. It is creating the bucket. It will add some tags to the bucket so we can later identify what bucket, what's the purpose of the buckets and other tags, and then do a copy of a file into the bucket to make sure we can properly identify this. You see here locations listed. From the location, the bucket name, as well as our environment information, re-extract information and save it in the configuration file. This would include the ARN of the bucket as well as the bucket name to utilize this later. So 2 buckets we have already in the works, which is the marketing and the sales bucket. Copies the file over, and then our next bucket will be done in a bit. This is all executing in live at the moment, and the reason why you see a little delay in here is because we configured to have a delay between the API calls. They're all asynchronous in nature, and therefore we need to kind of keep a track on if the resource is already properly deployed within AWS, and if we are too fast with our API calls, the resource might not have been properly created or replicated across the system. So now we have here 3 different buckets. Let's take a look at this in our console. We switch over to the S3 bucket console, and there we see marketing, sales, and shared. Our 3 buckets, they have no special configuration. So let's take a look at this one here. We have a folder already for marketing, and in there is a file that we copied over. And if you take a look at the permissions, that is the default setting that we have for the bucket. So as you execute this in your exercise here, keep in mind here is the ARN. If you click on this one, you can copy and paste the ARN of the bucket, and no other special settings are required. Okay, so far for creating our first resource, which is focusing on the bucket. And next we focus on creating the users. And again, you can pause this video here and do more research on bucket creation, either via the web front end or the API. We delve into creating our users. There's no relationship between the user and the bucket at this moment. They are individual entities, so to speak. So what are our requirements? We need to create 3 different user accounts, one for sales, one for marketing, and our shared one. I think about this as our administrator who gets special permissions for these resources. We utilize the AWS CLI. You can use the web interface, and the 3 different APIs that we keep in mind at this point is the create user, the create access key. This is the one that is really, really important because that gives you the secure access key and the access key that we need in later stages. They would be used for an S3 configuration, as well as for our IAM role definition that we need to have later. We add also 2 more calls, which is creating a group as well as adding the user to the group. Best practice when we access resources from the outside, or in generally speaking, grant access to a resource to a group and put users in that group. That makes your administration and your management so much easier. However, what I found out is that you cannot assign roles and policies that we need for IAM to a group. We need to use the user. Only if we use the secret key and access key, we can use the group thinking. But for IAM, groups are not supported, only individual users. So keep that in mind as you go through the exercises yourself. So let's do the next one that we want to execute. In this case, we are not creating buckets. The next one is our user creation. Let's run this one. And again, we have 3 different users that need to be created. This is relatively quick when the setup will be executed. However, after we have now the user created, we need to have some additional steps because we need to extract some data that we need for our roles and our permissions. And one of these aspects would be to set the secure access key and access key, create a new one that we can utilize and save for our purposes. So here you can see we created now the 3 different users, and now we iterate through the first user, the marketing user, and create the access key. You can see this is the first access key. In total we have 2 access keys that you can specify. Since this is a brand new user who doesn't have an access key yet that we want to utilize somewhere, we just create a new one for the first position. And once this access key is created, we extract that data. You can see here we have the access key as well as the secret key in here, and we store this information in a local file that we use as we execute the different setup routines. And again, would be a time to have a quick coffee. This is our second user that we are creating and that we are managing. Remember, here on the top was the creation process, and now we are customizing that particular user. We create the groups and the memberships for the groups, and last but not least, our third user, the administrator with shared access. Just as a recap, the shared resources as well as the shared user are there to combine marketing and sales, and the shared administrator that we assigned is there to manage these resources accordingly. Okay, so this is here at the end, create the group, add the user to the group, almost done. There we are done, and we see here we wrote that information into a configuration file. This is where we keep the secret key, the access key, the user ARN, and all the other details of the user and group object. We take a look at this at a later stage. Now let's go over to our IAM portion and take a look at users. There we have 3 users: marketing, sales, and shared. Let's open up marketing. You see here groups and tags are set. Here's our group membership. And remember, IAM policies and roles, they don't work really well with groups. This is for the scenario where we want to use the classic S3 access with secret and access key. Okay, let's take a look at this. At the user one more time here, marketing. If we take a look here at secure credentials, you see here we have one access key. A secondary key can be created. You just click on this link and then use this one for your subsequent execution. What we need to keep track on is the ARN. We had the ARN of the bucket. Now we have the ARN of the user. So let's keep track of this one. And let's recap really quickly what we have done here on the user side. Currently, we created the user, and the only relationship that the user has at this time is with the group that we have for a specific use case. There's no relationship to a bucket or whatsoever. So it's an object by itself. Would be again a good time to review what user objects are in AWS and how you can create them with the GUI or via the API, and pause that video. We will continue with the roles at this moment and take a look on how now roles, policies, and users interact with each other. So here we focus on 2 aspects. One would be a role that represents the user's permission level, and a role that can be assigned to the EC2 instance in order for us to allow to change our head, to switch or to assume roles. The topics that you need to look into were assume a role and our STS. Remember, STS is the AWS Security Token Service. It is there to create and provide trusted users with the temporary security credentials that can control access to AWS resources. So that's what we want to focus on create. When we run the Control M agent on an EC2 instance and the agent needs access to AWS resources, we can provide these temporary security credentials to the instance, and then the agent can inherit these credentials and therefore have access to these resources. Focus here again is that is temporary in nature. So when we shut down the system, when we bring it up, there is nothing stored on the file system in terms of configuration files containing secret or access key information. So this is really, really important. The purpose of these keys is for temporary access of the resources. So let's go ahead and create these. So we have now roles that we need to create. And guess how many roles we have? Well, we have one role that focuses on the EC2 instance, and then we have for each of the users that we want to impersonate a dedicated role, which means one role for sales, one role for marketing, and one role for shared. And now you can see here we create the roles and get details from that role. In terms of the EC2 instance, we need to attach a role policy and do some tweak under the cover. And for our users, the roles, you can see we have now 3 different roles created in here, as well as a shared role that has specific settings, and this information is stored in our configuration file. Where do we see this? Well, in our IAM administration section, we go onto roles, filter for ZZM, and there we see our different roles. Let's take a look on marketing. In marketing, we have there at the moment no permissions, no the trust relationships are defined, and you can see here in the JSON, this is the assumed role that can be granted, and the roles would be for marketing as well as for the EC2 instance. Really important, if you are deleting and recreating your components and your objects with the same name, make sure that you refresh here the settings from time to time, otherwise old data will be there. So one thing to note would be our EC2 role. Remember, the marketing, sales, and shared focus on a very specific when it gets to accessing the S3 resources, and the EC2 role is very specific because that's the one that the EC2 instance needs to be able to access. Because here we have 2 policies at the moment. One is EC2 full access, which means the EC2 instance can perform EC2 actions. This is what we require to do the impersonation, as well have access to S3 resources. For this training, we focus not on the details of IAM, and this is not a replacement for AWS training. We just take a look at this, how we can benefit from these kind of configuration for Control M. So there's much more that you can learn in this area, and more fine-grained configuration can take place. We just keep it here very simple and grant EC2 and S3 full access. So let's refresh this one here one time, because I created this user earlier and deleted it. So here you really can see we have at the moment only 2. But there is a third one missing, the third policy that we need to associate. Remember, the EC2 instance is going to figure out what role and policy it can utilize in order to perform the assumed role and to take on and impersonate itself. Well, the third one is configured in another policy. But because the policy doesn't exist yet, this one here is empty. So in other words, when we create the policies, we need to go back in here and review that. So don't freak out if you don't see your STS policy coming up here. So let's recap really quickly. The roles that we have created focuses on users as well as on policies, mainly users for our S3 access and who can I impersonate. And for the EC2 instance, we needed to have a policy that we need to link. The policy doesn't exist yet, so as soon as we go into the policy section, we see the link between the role and the STS policy just for the EC2 instance. And that's what we're going to do next. Again, take a moment and review the material around roles and what kind of permissions you can grant and how the JSON under the cover looks like. So let's go into the policy. Now, remember from the picture that we showed earlier about the chain that we have and how they all fit together, the policy and the resources, they need to know each other. They need to link to each other in a certain way. And so this is why we see here in our learning stage that the policies have access to roles, and at the same time we've referenced the resources that we are going to access. So this is where our S3 bucket links come into play. So what are we going to do? We're going to create policies, two types of policies. One that focuses on the EC2's instant capability to grant us a temporary security credentials, that is the AWS STS, and another policy that focuses on the buckets. And in order to identify which bucket we have access to, of course, we need to have the answer on this. Again, we utilize the AWS CLI, but you can go for the web interface as well. The topics that you want to take a look at in order to better understand this is that we need to create an instance profile. We need to create a role to instance profile mapping. We need to associate them because this is where the instant profile and the policy is being handed over or attached to the EC2 instance. So these are some of the APIs and concepts that you need to take a look in. So let's take a look at this one here really quick. The next one is going to be our policies that we generate. On the first one, we focus on the IAM policies and resources. So we create the policy that we need, and we're going to take a look at the JSON in a bit, what that policy entails. And here you see we attach the policy to roles and to groups, and we repeat this process for the different roles that we have. Again, we have 3 different users, we have 3 different roles, we have 3 different buckets, we have 3 different policies. These are all roles and policy and users that are there for us to access the S3 buckets in a governed way. On top of this, we need to have the EC2 instance being able to impersonate itself for the sales, for the marketing, and for the shared. This is why we need to have a very specific policy and role in place that allows the EC2 instance to perform these actions, which leaves us in total with 4 different policies. So the last one you can see here, we create the STS policy and we create a relationship with each other. And again, keep in mind, when you execute this, pause a little bit, have a coffee or so, because it's an asynchronous execution. Okay, so now we have this in place. All the artifacts are being created or were created. Let's go back here, IAM. And this time we want to, we can switch over to policies right away, but I gave you already a hint that there needs to be a third one there. So let's do a refresh here and see if it worked properly. Now we have it. You see, now we have a policy and we can take a look at this one. And this policy allows the EC2 instance to impersonate different roles. And there are 2 ways on how you can create this. You can create a policy from scratch and have this managed under the policy branch here, or you can create an inline policy. Read up on the AWS documentation. So these are the 2 ways on how you can make this happen. I opted to have a policy, a dedicated policy in place, and I can use that policy for many different roles. If you use an inline policy, that means that is part of this particular role and will be attached directly. And again, you can read up with AWS more on that one. So here's would be our policy that enables now the EC2 instance to switch heads. Let's go over to policies and take a look at our ZZM policies. There we have marketing, sales, and shared. That's what we expected, right? And we have our EC2 STS policy. Again, use a naming convention that helps you identify what is what and what is it doing for. So let's take a look at marketing. Here we see we have now the S3 permissions assigned to it and gave it certain permissions. Interesting part is if we take a look at the JSON here, this is really interesting. All of a sudden we can see that this role here for this policy for marketing has now access to these S3 resources. And the reason why we have here the asterisks in place with list bucket, this portion here, this one is in play because we want it to be user friendly on the control M side. If we were to utilize only an API without exposing any of these things in the GUI, then we would remove this piece and have only the bottom one in place. And so in the bottom, we have now marketing shared in that particular policy. Noteworthy also is here the setting that we have under the allow section. We mentioned about the different buckets that we have access to, but you can see here the specification, the bucket name, and then bucket name / asterisk that allows us to have access to certain subfolders within it. So now we really looked onto the different policies that we have in play. Again, just to highlight marketing, sales, shared, and our STS policy. Let's take a look at the STS policy in the entitlement, and we can see here that now the role is assigned or attached to our policy that we specified earlier. Okay, so that summarizes the aspect of creating the policies. Now we need to bring this a little bit more together and entitle the EC2 instance with that IAM policy so that they can use that. That is going to be our next exercise. Taking a look again at the resource, but this time not at the resource from a bucket perspective, but as a resource from the EC2 perspective. And there we need to have in play the STS policy. And because we don't use the inline policy, this policy was created outside. And second, we need to have the AN information in regards to the buckets. And the API calls that we are going to utilize is the create instance profile, the add role to an instance profile, and then the association of that instant profile to the EC2 instance. So we are not going to associate the policy directly to our EC2 instance, but we are going to associate a profile of that policy to our instance. Sounds crazy, but that's the way it works. So let's take a look on getting this to work. And so this would be our path to actually create the association. So we want to attach the policy to our EC2 instance. Before we do this, I'm going to iterate through the different policies that might be associated with the instance and remove them. So if you run this over and over and over again, I want to make sure that everything is cleared out before. I also check if the instant profile exists already, and if it does exist, then to delete it, really to have a clean start, as I'm going to reuse the same environment over and over again for a demo. Now we see here the instance profile was being created. It will now be associated with the instance, and we extract some additional information. For example, we want to know the public IP address and the ARN, and as well as other information from the EC2 instance that we use in subsequent executions. Now you see here the association takes place, and all that information that we have from that EC2 instance is again saved in our config file. Guess what we're going to do? We're going to take a look at our EC2 instance. Open the instances where our filter is set, click on the instance, and now here we can see that the IAM role that we had created earlier is associated with this. So let's open this one up. And there we have now the details. We looked at this one before in order to make sure that the STS policy is associated to that role. One more thing I wanted to highlight. Let's go back to the EC2 instance. If you want to do this by yourself, remember you can create and change this one. So let's go over to security, modify the role, and as you can see here, there is not directly the role associated, but the profile that is being linked with that role. So that is the little fine detail under the cover, so that we are associating a profile of that role. Imagine the roles and policies, users, and all the artifacts can be used across the board multiple times. So I guess that's the idea of making sure that you can reuse certain artifacts. So now our instance has access to these different roles. What happens next? Well, we guess we need to have access to the API and really look into how Control M is utilizing this. So if you were to summarize all the different activities that we have performed, we granted temporary security credentials to a AWS resource. And with AWS Identity and Access Management, we can now specify who or what can access services and resources in AWS. We centrally manage fine-grained permission, and we are able to also analyze who has what kind of permissions across the AWS landscape. Now we want to utilize really these different resources that we have configured via the API. That falls under our topic of governance, because we created all these, a bunch of artifacts, and now we want to utilize the API. So in order to do this, we are going to execute a few scripts, because we see here in our AWS config file, we have all the details, and we want to set up our API properly. So let's going to create the CLI components. You might recall from the beginning of the video, we had the config as well as the credentials file in the API setting all empty. It was supposed to inherit only the EC2 instance permissions, but in this case we want to have a little bit more. So what we were doing here is extracting all the necessary information in order to create for us a credentials file. So let's take a look at this. We're going into the instance itself. Here again, this is our old credential file with nothing in there, and we're going to copy from we can do a copy from the setup directory, the credentials file. I thought I copied it over. Let's go quickly in there. Oh, I would type correctly. Oh yeah, it's in our project folder. There we have the credential files. So let's go back to our home directory into AWS and copy from the setup folder our project number, the credential file in here. And so where are we? We are in the users home directory .able AWS. This is where the AWS API has its configuration file. And now if we take a look at the credential file itself, wow, look what we have here now. In the beginning, we have the default. If we are not to utilize the any of these profiles that we have generated, it will use just the one that inherited from the EC2 instance. Which one is that? Let's go over to our EC2 instance. It would inherit this particular role and the permissions and access of these resources if we are going to use the default. Now, because we have 3 different teams, 3 different buckets, 3 different roles, as well as an S3 focused and one of IAM focused profile, we can see all them in here. The first one is utilizing the role ARN, and you can see here this is the role ARN for marketing, and it uses the profile marketing. So if we were to go into profile marketing, in profile marketing we have the access key and the secure key. And don't worry, you don't have to write this down, because at the end of the session this is going to be deleted. So if we were to use in our AWS CLI commands the marketing profile, it is focusing on access key and secret access key. This can be utilized anywhere in the world as soon as you have the AWS CLI installed. Next one, however, if we take a look at marketing here, the marketing profile that we have uses the EC2 instance metadata, which means we don't need to have an access key ID, we don't need to have a secret access key, because we provided the role ARN that is going to be used to impersonate that role. So what happens under the cover, if we say we want to use this particular profile, our provider chain will evaluate if the role ARN has the permissions to execute and access certain resources by means of the roles and the policies. What does it mean for Control M? Well, for Control M, we need to do the 2 things. We need to copy and paste the role ARN that we want to use, and we need to tell the CCP to enable the default provider chain evaluation path so that it can utilize this. So in order for us to test this, let's run a few things here. First, we're going to list our directory structure. So let's clear the screen here and do an AWS S3 LS. And the bucket that we want to look into is CZM. And then let's go back really quick. I forgot my bucket name. CZM, and you see here, and this is our bucket for marketing. So all we have to do is just copy and paste this piece here. In there, and what do we see? We don't have access. Now, why do we have no access? Because we didn't specify which profile we want to use. The default profile doesn't have access to marketing. So what we need to do is we need to tell the API, use the profile IAM marketing. Oh, yeah, another thing that we were missing is this // And there we have it. We have now access to IAM marketing. This was the folder where we uploaded the file. So let's do the same thing for sales. And take a look if we have access to the sales bucket. And there we have a different folder, which is sales. Now, just for fun, let's do that for shared. And guess what? The bucket is called shared. And there we have a folder that is .aws and IAM shared. In AWS, in the last script that we were executing, I uploaded the details into that bucket just for training purposes. Now let's copy a file over and see if this is working. So in order to do this, we invoke the AWS S3 command to copy a file, and the file that we have is going to be in our setup folder, and it's just file name called sample bin. And now let's copy this one over to the S3 bucket, and our number is, and copy this over to shared, and in temp folder and copy is working. Now let's do the same thing and do this with profile sales. Okay, oops, dash. Profile sales as well as IAM sales can copy a file over because they have permissions in the shared folder to access this. And let's try the same thing with marketing. Okay, and so we can see here we can upload files into the shared folder with the different profiles. And now you can make an Excel spreadsheet and check which profile has access to which folder, what can they see, what can they access, and so forth. Based on the permissions that we have set, sales can access the shared folder, marketing can access the shared folder, shared can access the shared folder, and maybe some others, depends. We have to look at the actual JSON of the role and the policies. However, marketing cannot access sales, and sales cannot access marketing. Now, a little thing here to note. You see here, I tried the profile sales and the profile IAM sales. Now, why did sales work on this machine? Well, sales, as we mentioned earlier, contains the access key ID and the secret key. So anywhere in the world, that particular copy command would work if we have the proper credentials in there. However, IAM sales would only work where? Maybe a good question for our FAQ section. It would only work where we have IAM configured properly and where the role profile is associated with the EC2 instance. And since we are here on the same machine, we can utilize both. But if you were to copy this configuration file, this credential files, we were to remove the one that have access key and secret key and have only the IAM details in there, they would not work anywhere. So this makes it really secure on focusing only on IAM. If someone gets hold of that file and the instance doesn't have that permission associated, it could not inherit any of these access resources. Okay, so what we looked at was the configuration of our API. The script that we were running in the background was extracting all this data from the object that we created, made a config file, made a credentials file, and copied this over to the EC2 instance. And this is where we utilized the public IP address in order to do an SSH and an SCP over to the environment, and we were able to access that credential files. So by default, this file would not exist on your EC2 instance. Just our script did this. And areas for you to look into when you create connection profiles would be the access key ID and the secret access key when you want to attach yourself or open S3 buckets from anywhere. However, if you want to bring it down and use IAM, then the connection profile needs to have the role arm as well as the credential provider chain enabled so that this works. Okay, so what we have looked at so far was only focused on AWS. We touched here and there a little bit on how that impacts Control M, but now we want to take a look a little bit deeper into a data-driven execution and how it would impact us. And for this reason, we need to have all the AWS resources in place, all the policies, all the roles. They all need to be married to each other properly and work together. We need to utilize we want to utilize the automation API to automate our process instead of the GUI. And what we are going to focus on is Control M secrets, because when we create an S3 driven connection profile, we don't want to have that secret access key part of our JSON. This is where we utilize secrets. And when we create the connection profiles with IAM, we have some optional parameters that need to be set. So this is our task right now, to create the connection profile and a little bit more. So let's take a look into how that works. We go back to our console here. And in this case, we are focusing on Control M resources. So CTM, what we want to do, we want to create the connection profile artifacts. We want to test the connection profile, and everything is working. You know what? Why don't we just deploy the connection profile and make it work? So let's hit enter and see what happens. So we have some details about our Control M environment. And now we're going to extract the data from our configuration JSON, and we create new JSON files that are responsible for the connection profile, that are responsible for our folders, and update all these settings. And we're going to have multiple connection profile. One that focuses on the S3 integration with the secret key as well as the key ID, and another one that focuses on IAM, so that we can actually test and take a look at both. All of these were created now, and now let's take a look at the Control M environment. I like jobs as code, and so in my VS Code, I have an integration loaded that is community driven, that focuses on all the components that I have in my environment. And you see here secrets right now. I have 0 secrets, and when I look at the connection profiles, I have here base profiles, file transfer, and you see here there are 5 definitions in there for different connection profiles. So what I'm going to do is I'm utilizing this integration to execute some APIs and retrieve configuration data from Control M. On the main screen where we see the script that was executed, it did all the CTM config. You see here the config of deleting the secret, so get rid of the old stuff, adding a secret that we can use, and then do a config test, a deployment test, as well as deploy the connection profile. So the API script did all that for us in an automated fashion, and I'm just refreshing this tree here, discover the Control M environment. I click here on output for a second, make this big screen, and now we see the different API calls in play in order to retrieve how our Control M environment is configured, with the agents, with the connection profiles, and so forth. And this is all under the umbrella of jobs as code, where I would like to utilize the APIs. Now we can see here, as this one was being executed, that we have now 3 different secrets. And you can see here, this is our project number, and the secret is called marketing, sales, and shared. And guess where we're going to use them? Of course, they're going to be used in the connection profile that can be utilized anywhere from any Control M agent that is focusing on these setup credentials. Now let's take a look at our role definitions. You can see here, there's one that starts with an I, and there's one starts with an S. I is for IAM-based connection profile. So if I open this one up, you see here, this is a file transfer connection profile for S3. It has the access key, and look at this access key. This could be just gibberish. And guess why that works? If we have an access key that is gibberish and the secret key that is whatever, well, it works because we have additional parameters set here. And take a look at these 2 additional parameters. One is the default provider chain is set to true. And the second one, let me make the screen bigger. The second one is the role that we want to utilize. We just did this a couple of minutes ago with the AWS CLI command, and now we can see exactly the same thing with the connection profile, that we are going to instruct the agent to utilize the provider chain and hand this information over to the EC2 instance. And because the EC2 instance has the IAM role profile associated with it, it can then utilize these kind of settings and give us access. And the reason that we can say this is working, because we do a CTM deploy with connection profile test for each of these settings, one time for S3, one time for IAM, and they're all working. And because we have multiple of these, it is because each team has their own connection profile. So we use some naming convention here. You see this one is for marketing, this one is for sales, and this one is for shared. Now, why did I make them closer and not have something human readable that is super duper long? We'll find out in the next segment why that is the case. So here we focus just connection profile is created and tested. And if we take a look at the one that is starting with an S, this one doesn't use the provider chain. So this one needs to have the secret key and it needs to have an access key. And when I get this configuration from Control M, the secret access key is not going to be displayed in clear text. So far so good. We have all the pieces in Control M. Now let's take a look at the artifacts that made it possible. Here's our project folder. Let's move this one in and take a look at our CTM. I copied over the different connection profile definitions. Let's take a look at this one here. We see this is the name of the connection profile. The access key, the secret key is in there as well. So this one, these two can be gibberish. That doesn't matter what it is, because the role arm and the value that we have here are responsible for that information. Yeah. If we take a look at the marketing one, the marketing one has the access key, which is properly formatted. That must be the access key. And it has the secret key ID, but the secret key ID, so to speak, the secret key, not the secret key ID, the secret key is a Control M secret. So this piece here is going to be replaced on the fly when we are deploying that connection profile. Okay, now that would be this particular piece, and we can also test this from here. Right mouse click, jobs as code, and do a CTM build, run and deploy. So let's do a CTM build and let's take a look at the output. And you see here, this connection profile can be built properly. If we take a look at the IAM one, right mouse click, build. Yes, it built it properly. And so this one is wonderful working. And if we want to have this with a different name, we just can change this name here and say, I'm the T1000, put a T1K in here, save this one, right mouse click. Yep, build was successful, and then let's do a deploy. So it deployed that connection profile with a new name. And so this is the beauty of jobs as code. We have it right there and don't have to click for the GUI. How would that look like in real life when we execute this? Some best practice. So before we go over and take a look at the folder that is executing, let's review just really quickly how would we bring these pieces all together and make it really work. Because the whole idea is of managed file transfer to be a good citizen in the overall execution and have then secure access to resources that are in the cloud. And here you see an animation running of a folder that is going to be executed. In different aspects of this, you see integration in AWS that needs to pull or push data, Apache Airflow and Azure integration. At the end of the day, run some business jobs on SAP. So this is where MFT really fits in, that we are citizen of a whole chain and behave accordingly and do all the rest. And because we want to have that access in the cloud in a secure fashion, we utilize IAM. Now let's take that thinking and do some sample jobs. Okay, so move over here. We can close these two. and take a look at the S3 job that we have. You see here, this is our folder that we have. And in the folder, we have different jobs that are going to be executed. So let me make them a little bit smaller here. So the first one, or not the first one of them is going to be just do a directory listing of the S3, copy a file over to the marketing department, copy a file over to sales and to share. And then interestingly, look at this one here, copy something from marketing to sales, which is absolutely powerful. Okay, where were we? The special job that we have running is from marketing to sale, where we can see the connection profile that is being used to go from source to destination, moving data from sales to the marketing department. So this is what we try to attempt and see what happens. Do we have the permission for marketing to move over to sales? Well, let's do this. We focused here in this job that is being executed to have as much of these settings as parameters. You see here there's the bucket names that can be updated on the fly. So we're going to build this one. Yeah, we get a few error messages here from past API. This is good to ignore. Then we're going to say deploy this one. Okay, deployment is successful. Now we go over and switch to the Control M environment and take a look on the job and its execution that we trigger from there. Okay, we just deployed the job. It's the training for S3. We also have the training for IAM. So let's open up this workspace. Here are the different jobs that we have created. Copy sales, copy to marketing, copy to shared. So this is all from the local environment. And then we have intertraffic, which means from one bucket to another, directory listing, and we have marketing to sales. So let's execute this one and then we take a look at this in more detail. Okay. Here's our job being executed. The first one is doing a copy of the local file into the sales. And we see this one was successful from the local file system. Here our connection profile for local file system, utilizing the S3, which is our secret key and access key ID connection profile. So this one is working. This one focuses all on the classic setup, moving a file into marketing, moving a file into share, moving a file between buckets. And so here we see now the different buckets. It's using this sales to marketing, so we can copy files between different buckets. I call this one intertraffic because it all stays into the cloud. We do a directory listing, works as well. And this one here is failing. And so now if we take a look at this one, this is now where we try to utilize the marketing connection profile and copy something over, but the role that is, the details that are associated to this connection profile, they don't have a permission on the bucket that is being used. So on purpose, we are getting here access denied because marketing is not to have access to the sales bucket. That is why this one is failing on purpose. And we can see the bucket name here on top. So the marketing connection profile is trying to copy files or access the sales bucket and no access granted. So this kind of access is possible because we are using the access key and the key ID in the connection profile. And just as a reminder, this particular flow can be executed on any agent. Okay, now let's switch over. And how does that apply to IAM? Let's go to our planning domain and we load up the training one for IAM. And in this case, we only have 3, which is copy over, transfer, and directory listing, because we already proven that we can access AWS resources. No need to replicate the other jobs. So let's execute them. Take a look in our training. And here we have now the second flow running. There it comes. IAM training. There it is. So the first one, again, it utilizes the IAM connectivity. Copying of the file is possible. Now, why is that possible? Because we need to be on the agent that is running this. So if you take a look here in the job settings, to be more precise, the agent that we are using to run this is this host group ZZM AWS. The agent behind that, the agent that is in that host group, is our EC2 instance. That is why the IAM access to these resources is working. And again, we using variables here to make this reusable. Copy the file over to marketing. Great, is working. The next one is going to be a directory listing. So let's take a look at the output. It's also working. And again, the connection profiles that we are using is for IAM. This is the I in the front. And we're looking at sales and at marketing. Now imagine, here now we have the power of IAM. A user only with the proper permissions can access these resources, and we are able to utilize both connection profiles in our job, which means we do an assume role for sales and we do an assume role for marketing in the same job, and then copy files back and forth. Now the last one is failing, and we call this one intertraffic. So what was supposed to happen is moving file from one bucket to another. And if you take a look at the connection profile here, we were supposed to utilize the sales connection profile with the sales bucket, which is according to our roles and policies. That should work. We should have access between sales and sales connection profile and sales bucket. And the other one is marketing, and it's the marketing bucket. So why is it not working? Why can I not copy over from sales with the right role over to marketing with the right role? Directory listing was working. Why isn't the copy not working? Well, this is really where the rubber meets the road, so to speak, if I may to use this word picture. Because the agent and therefore the connection profile will inherit whatever permission the machine has. And if we are running this connection profile on a machine that does know nothing about the credential provider chain, that does nothing about AWS, it will never work. And you can see here the host group that we are using, this is just an agent on the Windows machine, on the Linux machine running on an ESX server. So it would never work. So if someone were to copy the IAM credentials and the settings over and tries to run it from somewhere else, it will always fail. This is where you see how we can make this secure and add governance around accessing these resources. And with role-based access, we can specify who has access to which folder and job and connection profile. Now to prove that it's actually working, let's go and edit this one and change this from a local Linux agent to our AWS agent. Remember, the AWS agent, if we go back here to our EC2 instance, take a look at this one, open this up. He has the role to assume roles, so the STS assume role permissions. It can change the role and therefore can be the sales team or the marketing team, and in this case, both of them. So let's save this one here and rerun it. Time for a coffee. Might take a few seconds to move that over. So let's take a look at the output. job finished, successful. And now we see here the files from one environment to the another were properly moved over. The buckets are properly identified. The connection profiles are properly identified. Now we see the power of IAM with connection profiles Control M working properly, as well as denying access if it's improperly configured. So if we were to summarize what we have learned in this session, it was all around governance, making sure that the right roles and users that are identified and authenticated have access to the resources in the right way. And from an IAM perspective on AWS, it required us to have an EC2 instance with a Control M agent running. This instance must have the permission to put on a different hat, in other words, to assume a new role, to change identities. And based on the roles and policies in place, we control or we govern which roles, which resources they can access. And at the end, we brought it all back together and executed a data-driven flow where we move files from one bucket to another, from one environment, from one agent to another, and utilize Control M manage file transfer in the concept of a data pipeline or any other process that needs to move files. There will be some additional questions that you will have, so feel free to reach out to the community, and yeah, that's about it. Now, let's take a look a little bit under the cover what I have done in order to get this to work. For each of these resources, to create the buckets, to create the roles, or to create the policies, there is a shell script that is using the AWS API as well as the Control M API. In this one here, you see I'm using again some AWS APIs to make this all work, to create the different artifacts and then bring them together. And then at the end of the day, provide a means for me to automate the creation of the configuration for the CLI. The purpose of this is to be able to test outside of Control M that the setup is working properly. And once this is all working and tested, then take this information and create all the artifacts in Control M. So let's take a look on how we are driving this one. You saw a little bit already, I'm having here a structure that creates the different resources. There are the scripts in place that create the different components. So if we start off with the bucket one first, and be here in the bottom, this is all driven based on our production file where we extract this data. So let's take a look at that production data. Is this configuration file that we saw popping up once in a while. And let's go through this a little bit here. So first of all, we need to specify what is our project number, so the code. So I put in a project code in here, the region that you're going to deploy this. And since we are trying to reuse this over and over again, I wanted to implement a certain naming convention. So there's a naming convention for the policies, for the roles that are in place, and for other artifacts like the buckets or the user. So all start with the acronym ZZM, and then different policies will be applied. A word of caution, in some of these areas, we require to have everything in lowercase because the API and the AWS resources require this. So even though it's human readable with capital letters in here, some of them we translate into lowercase. And once the scripts are being executed and extract this data, then I update here the settings. For example, you see here the ARN of the bucket as well as the full qualified name, because this is my short name and this is the full qualified name, how these resources will be generated. The same applies to the users. With the users, we have the ARN, the full qualified name from an AWS perspective, as well as the secret details that are in here. So at the end of this project, this will be all deleted and it's gone. We apply this one. And then here in the end, go into the EC2 instance to specify how do I get to this machine. And so here, this is the instance ID that I'm running, the PEM file that we downloaded for this, the user that we use. And as the AWS API is actively configuring the relationship of the EC2 with the role, then we have the machine obviously up and running and the public IP available. So I'm extracting that public IP, put it in here, because the SSH commands that we execute to upload our credentials file and do something with it, they need to have that IP. From a control M perspective, the name of the environment. So if we were to use this in your environment, just update this one. The agent, this is here. This is really special. This is important because we have multiple agents out there that can execute components, and when I want to deploy a connection profile, I need to provide some of these details. So this is the agent name that is actually running on that EC2 instance. And then we took a look at the demo folders that we're executing. So for S3 and for IAM, what are the demo folders? Because in the demo folder itself, and this is really a nice way for reusing this, rather than for me to updating every job that is running in there, I'm using control M variables. And so all I need to do is update here the variables on top of the folder, and then during execution they will be just applied to it. So this is a little bit behind the scenes on how this is all working. And now let's do this while this one is running. Let's open up our terminal again. And you know what, I can just go back in here, and there we have a XYZ flow. And this one I just call delete, and let's see what happens when we just run the delete. So again, if you want to reuse components and do different demos, the first thing that we want to do is we need to detach the policy role that we have, or the profile of that role that was created earlier and attached. We need to detach it from the EC2 instance. Every time we change something on the IAM side for the EC2 instance, from a script perspective, I always go and detach it first, so that there's no artifact left behind, because the AWS CLI is asynchronous in nature, and so I really want to avoid any old stuff to be around. So detaching it first, then going through and iterate through all the policies that we have and remove all the policies. That is the STS policies as well as the S3 related policies. Get them all cleared out. So here I'm going reverse from what we were doing before. So after the policies are all done, we're going to execute the roles. So this one is still running. So let's take a look over at the EC2 instance and see how that looks like. So here, this is still in here. We need to refresh it. And all of a sudden you see here the role is gone. So if we now were to execute the folders and the jobs, they would all fail because we have no role associated to it. Okay, policy is still working and updating. As this is running, let's take a look really quickly on our configuration file. There's a setting here all in the top, which is the sleep between of these different calls, 15 seconds of sleep, so that I can keep up with the manipulation of the objects in AWS. Otherwise, the deletion process and other things will just run so fast that they cannot keep up with each other. So deletion of certain artifacts require that they're managed properly. So let's take a look at the policies here as this is running through. Policies were in our IAM. Go over to policies, EZM, and you see we have two more policies left. One is the one for shared and the STS, the other one's already gone. Keep in mind, you have to click on this refresh button once in a while to make sure that the GUI is updated. So I will let this run, fast forward the video in a second and show you how that looks like at the end. So you don't sit there and drink too much coffee. Oh, that was quick. Now we have the roles. So let's refresh our policies. Okay, policies are all gone. Great. Next one is the roles. Already run role is gone, which is the one for marketing. And by the way, while this is running, let's take a look at the log file. I got inspired by our prog log. Sorry, close this one. Prog log, CCM, AWS, and here, these are all the commands that we're executing to deleting pieces. Oh, right now we are by deleting users. So let's take a look at our roles. All roles are gone. Very nice. And the users is already done with the users. So let's take a look at the users. Okay. Our project users are all gone. And the last one were the buckets. So the buckets are really interesting. I can't just go in there and delete the bucket. We need to empty the bucket first. So these are two different API calls that need to take place. And if we look into the log file, you will see here how it's deleting the buckets and first emptying the buckets first and going through this. This is already delete the user. Let's see where our buckets are. Okay, you get the idea. I'm not going through all of this. Buckets are already gone, so let's take a look at S3. ZZM, no more buckets. All the buckets are emptied out and deleted. And the last one was our connection profiles. So we want to update Control M as well and remove the connection profiles. And here I'm just utilizing again the integration that we have here with VS Code. Refresh this one. Okay, discover. Let's take a look at the output and what it's doing. It's running the discovery process. You see all the different APIs that will be executed. We have here 3 different secrets, and we have connection profiles here under file transfer, a few in there. So this one is still running, getting the data, and then it will update the tree. And so we see no more secrets, all the secrets are gone. And when we take a look at the connection profiles, here we have, look, one is left. This is the one that we didn't have in our JSON as a project connection profile. Remember, I put in the T1000 in here, custom outside of the script, but all the other ones that related to our project and are part of the scripts are all deleted. So this is all nicely cleaned up, and now no attack surface left behind for anybody to try to hijack the infrastructure. Everything is nicely cleaned up. Okay, so that was a view behind the scenes. This ends the session about utilizing AWS IAM and the different setups with a Control M data pipeline. I hope you found this training to be beneficial to you. Recommend us further. Thank you for your attention.